In today's video, we're going to look at the difference between congruence versus similarities. Now, in previous lessons, I talked about the difference between congruence and similarity, whether something is congruent or something is similar, but it's not exclusive. You can have situations that are both congruent and similar, and or you could have a situation where they're neither congruent or similar. So to refresh our memories, congruent means same size. So the size is preserved. Similar means that they're the same shape. Okay, they might have the same angle measures, but pretty much the same shape. And after, because usually a dilation is done to make it bigger or smaller. So in the first problem, we're going to have two figures. It looks like being transformed. Okay, this one is being transformed to here, and it looks like the size is preserved. So that means it's the same size and the shape is preserved. Okay. All these angles look the same. It looks pretty much like it was either rotated, reflected, only rigid motions were being done. So this one is congruent, and rigid motions can be used to map from here to here. It is also similar because going from here to here, the angles stayed the same size. The angles didn't change, okay? Because dilations can be used to map this onto that. And remember, the scale factor, if it stays the same size, the scale factor is 1, okay? So it is congruent because rigid motions can be done. It's also similar because a dilation with a scale factor of 1 is being done. Okay, so that's a situation where, look, it happens, it rotates, then flips. The size stays the same. It is similar. Scale factor is 1. Now, let's look at it similar but not congruent situation. Okay, so this one, it looks like, okay, it is not congruent because it's not the same size, because rigid motions cannot be used to map from one to the other. But it is similar. It is similar because dilations can be used to map this onto this. Okay. So whenever it is similar, dilations can be done. Now, what's the scale factor? Let's look. I don't know. Let's look at this one right here. Sorry, this is 2 blocks right here. This is 1, 2, 3, 4, 5, 6. Right. Now, hold on. I gotta make sure I'm going in the right direction. Yep, it's going from here to here. So from 2 to 6, the scale factor is 3. Bada boom, bada boom, and it boom. There we go. So look at that. It's being slid and then transformed bigger. Okay, let's look at another similar but not congruent scenario. Okay, is this getting bigger or smaller? This one's getting bigger. I want something that gets smaller. Okay, right here. Perfect. Okay. So this one, A, B, C, D, E, it's not congruent because dilations are not done. So rigid motions cannot be done. It is similar because dilations are done. And the scale factor, okay, let's going from here to here. So AB is 2, ST is 1. So when it goes from 2 to 1, you just the scale factor gets smaller by 1 over 2. So that is the scale factor. Bada boom, bada boom. All right. Let's look at one more. Maybe like have a smaller scenario. No, that's bigger. I want smaller. I want smaller. Okay, right here. Okay. This, not congruent. Okay. Rigid motions can't be done. It is similar. Dilations can be done. Now, HI, it looks like that's like at the, it looks like it's being rotated then, or dilated then rotated, one or the other. Okay. So HI is 1, 2, 3, 4. It looks like that congruent side, HI, is CD right here, which is just 1. So if it goes smaller from 4 to 1, the scale factor is 1/4. Submit. Yes. Okay. One more. I want to see one that has a scale factor that is a fraction. Is that possible? No, not this one. If not, we can figure it out. Um, Here we go. Here we go. Okay. So this one, IJ, okay, this one, again, getting smaller. It's not congruent. Ridge of motions can't be done. It is similar. Dilations can be done. All right. JK, it is 1, 2, 3, 4, 5, 6. Okay. That looks corresponding to here, which is 4. These are 4 blocks. So it is getting smaller by 4/6. Now, when I reduce the scale factor 4/6, that reduces to 2/3, right? You're not going to see 4/6. You're going to see 2/3. So, ask for a fraction and then end up happening. Now, so those are all situations where it could be congruent and similar, or congruent, or I'm sorry, similar but not congruent. But you could have a situation where it's neither, not similar whatsoever, like this one. This one, it looks like it's being warped. All right, so let me clear this ink. This is being warped. It doesn't even look like it stays the same shape. So if it doesn't stay the same shape, it is not congruent. Ridge of motions can't be done. It's not similar because dilations can't be done. And so it is not even, it's neither, pretty much. Okay. So sometimes you're going to have that scenario. All right. So that's it for today's video. Thank you for watching. And always remember, whether you're solving for X or Y, always give math a try.